Good afternoon, sir. So this afternoon, I have five samples problems about pressure. This culminating activity in module 3. So now we have the sample here in sample number 1. So a sample of nitrogen gas was placed in a flexible of 9.0 liter container at 300 Kelvin at a pressure of 1.5 atm. The container was compressed to a volume of 3.0 liter and heat was added until the temperature reached 600 Kelvin. So what is the new pressure inside of the container? So now let's find first the volume 1, 9 liter. Our T1 is 300 Kelvin. Our P1 or pressure 1 is 1.5 atm. Then our volume 2 is 3 liters, and then our T2 is 600 Kelvin, and our P2 is unknown. So we are going to find the value of P2. P2 means pressure, second pressure. So now we are going to use this equation or formula. So P1 times B1 over T1. So P2 times B2 over T2. So now we are going to write here the value of our P1. So our P1, the value of our P1 is 1.5 atm. Then the value of our V1 is 9 liter. Then the value of our T1 is 300 Kelvin. So now we are going to write here the value of our, this one we cannot put the value because this one is unknown. So later we know the value of this P2. So now our V2 volume 2, meaning to say the value is 3, and then over the T2 the value is 600. So now we are going to cross multiply this one. So 1.5 times 9 times 600, the answer is 8,100. So we are going to multiply 300 to 3. So the answer is 900. So now the value of, now we are going to divide this one. So 810 divided by 900 is 9 atm. So this is the value of our P2. So in problem number 1, this is the answer. So now we are going to the next problem in number 2. So a 20 liter container holds 0.50 mole of the helium gas at 335 Celsius at a pressure of 628.3 torr. So what will be the new pressure inside the container if the volume is reduced to 12 liter? So the temperature is increased to 177 Celsius and 1.25 mole of additional helium gas was added to it. So now we are going to find V1 20 liter, and our N1 is 0.65 mole. Our T1 is 37 degrees Celsius. So since it is a Celsius, we are going to convert into Kelvin. So what we are going to do here is to plus 273. So the result is that is the absolute of Kelvin. So 310. So the next is our P1 is pressure 1 is 628.3 torr. So our V2 is 12 liter. Then our N2 is 1.9 mole. And then our T2 is 177 Celsius. Then we are going to convert into Kelvin. We are going to add to 73 to become Kelvin 450. So our P2 is unknown. So now what we are going to do here is to solve or multiply. So we're going to put here first based on the equation. So the value of our P1 is 628.3, and the value of our V1 is 20, and the value of our N1 is 0.65 mole, and then the value of our T1 is 310. And then later we know the value of our P. So since we have no value, so we are going to write down the P2. So and then the value of our V2 is 12 later. So the value of our N2 is 1.9 mole, and then the value of our T2 is 45 atm. So now what we are going to do here is to cross multiply. So we are going to multiply this one, 622.3 times 20 times 1.9 times 450. So the answer is 10,74,393. So the next is we are going to multiply also 0.65 times 310 times 12. The answer is 2,418. So now we are going to divide. So the result is our P2 is the answer is 4443.3. So that is the answer of our problem number 2. So this is the pressure 1. So meaning to say we are going to this is the answer of problem number 2. So we are going to move problem number 3. So let's start. So the pressure of a gas decreases from 820 mmHg at 80 Celsius to a pressure of 95 kPa. What is the new temperature in Celsius? So now we're going to write here down. The P1 is 820 mmHg. So to become kPa, so we are going to write here 1.0.3 kPa. So now this one we already converted this one. So from mmHg, millimeter mercury, to kPa, kilopascal. So that our T1 is 80 Celsius. So to become Kelvin, we are going to add 273 to become Kelvin. So now our T1 is 353. So the next is our P2 is 95 kPa. So since it is kPa, we are not going to convert it to kPa. So now our T2 is unknown. So convert it into so now how to become this 109.3 because of the conversion. So this one. So knowing that how to convert mmHg to kPa, so first we are going to write here the 101.3 kPa is equivalent to 760 mmHg. So we are going to write here the 820 mmHg times 101.3 kPa divided by 760. So then the answer is 1.9.3 kPa. So that's why we put here 109.3 kPa. This is the P1, our pressure number 1. So now we are going to solve based on the equation that we have. So P1 over T1, then P2 over T2. So these equations is equations of Charles law, Gay-Lussac's law, because the volume is constant. We have no volume of this problem. So now 109.3 this is our P1. 353 Kelvin, this is our T1. So 950 kPa, this is our P2. And then our T2 is unknown. So unknown. So now we are going to write here the P1 300. Oh no. Before that, we are going to cross multiply. So 353 times 95. I try to run. So 393. 353 times 95. The answer is 33,535. 33,535. Then we are going to write down here, because we cannot multiply it because this one is no value of t. So we write here down. So 100 or 109.3 T2. So we are going to divide both sides. 109.3. We cancel out this one to get the answer of T2. So 33,535 divided by 109.3. So the answer of our T2 is 306.8 Kelvin. But before that, that is not the final answer because it is a Kelvin. So what we are going to do is from Kelvin we convert to Celsius. So now we are going to convert Kelvin to Celsius. We are going to subtract 270 to 73. The answer is 33.8 Celsius. So this is our answer in number 3. So this one meaning to say however we convert to, so meaning to say this is our final answer, Celsius. So the next is 5 samples. So we are going to continue about pressure. So in problem number 4, the pressure inside the tank is 4.3 atmosphere at the sea level. So what is the gauge pressure inside the tank? So we are going to write the equation here. So P pressure gauge equals P temperature minus P atmosphere. So our PT is 4.2 minus 1 atmosphere. So our PG is 3.2 atm. So in problem number 5, if the gauge pressure inside a storage tank is 0.9 atm at the sea level, then what is the gauge pressure inside the tank? So PG is equals to PT minus PA. So now our PT is 0.9 atm. Our pressure atmosphere is 1.1 atmosphere. So now we are going to minus. So the answer is, we are going to subtract, and the answer is negative 0.1 atm. So that's also that is all, sir. So this is the last video of my culminating activity. So that is the I'm done, sir. Thank you.